Chapter 3 Uniform Flow Computation. A flow said to be uniform, its properties remain constant with respect to distance. If the flow depth is constant along the length of the channel, the flow is said to be uniform. Mathematically, when y1 is equal to y2, y1, y depth of flow at section 1 equal to depth of flow at another section, which is a distance between them, then the flow is known as uniform flow. Also, area is constant, so Q equal to AV, area times velocity. When y is constant and area is constant, so the velocity is constant. Okay. This is the longitudinal section of flow in a canal. This is y at section 1, this is y at section 2. Both of depth are equal, so the flow is uniform. This volume between section 1 and 2 called control volume. It has a weight downward, W, weight of water. It divides into two components, W sine theta according to the direction of flow and W cosine theta to the downward. And so we have force 1 and force 2. This is analysis for the flow, and the dot line is the energy line, V square over 2G. Chezy equation. We have some equation to calculate the parameters of flow in open channel for uniform flow. One of them, Chezy equation. Velocity in the channel equal to C root 2R is. What C the factor depends on the surface of flow and the nature of the bed and sides, which is rough or smooth. This and the R is the hydraulic radius, S naught is bed slope. Okay, this equation known as Chezy equation. C has a dimension root 2L divided by T, and we have a relation between F, which is friction factor, and C. Friction also depends on the degree of roughness of the bed and sides. C is equal to root 2G over F. If we have F, we can find C by this equation. The second well-known equation of uniform flow is the Manning equation. Manning equation, V is equal to 1 over N R power 2 by 3 times root 2S. This is for metric. For British or foot system, just 1 is converted to 1.486. The same equation, just this coefficient is changed. So V is a mean velocity, and roughness coefficient is also related to the roughness of bed and sides. R is the hydraulic radius, S is the bed slope. We have a longitudinal section like of the channel. This is, for example, sorry, this is a slope. This theta is a longitudinal slope. We have H, which is difference between two ends in vertical, and L, difference between two ends in horizontal. Slope is equal to H over L, or delta H over L. By comparing both Chezy and Manning equation, we obtain the following formula, which is C equal to 1 over N R to the power 1 over 6. This is the relation between N and C. Okay, if we have C, we can find N, or we have N, we can find C. And previously we said that C is equal to root 2AG over F. So n is also has a relation with f by the following: f equal to n square over r 1 by 3 times 8g. So if we have f, we can find n and c, okay, and opposite. Factor affecting the roughness coefficient. We have some factors that affect the Manning roughness coefficient value, which is n. First, surface roughness. Its surface is concrete or tile or brick or soil or any other material. We have a special table. We can find the n Manning roughness coefficient, or vegetation cover, if this surface has a vegetation or not. Cross section irregularity. It's regular or irregular. It means geometrically regular or irregular. In regular we have a rectangular, circle, trapezoidal, and rectangular and triangle sections. Channel alignment irregularity. In the plan, if the channel like this, for example, like this is at the plan at the top, this is irregular. This is true for rivers, not artificial channels. Also, the cross section of rivers is irregular, like this. Maybe this is cross section of river. The water level may be here, but in the channel artificial we have a straight, rectangular, or trapezoidal, or any other regular shapes. Equivalent roughness coefficient. What's equivalent roughness coefficient? In some channels or rivers, the material at the bed are vary from sides, so we cannot use only one value in the entire channel. For this case, we divided sides and bed with two different value of n. For example, this is artificial channel. Its bed is concrete and sides is earth. So sides have n1. This value differ from the bed, n1, and the bed is n2. Okay. So for this case, for example, n1 is equal to 0.02, n2 is equal to 0.012. How we can find the just one value for Manning roughness coefficient? By the following equation: n equivalent equal to summation ni to the power 3 by 2. Summation n, all n's are summed by the power 3 by 2 times pi weighted parameter of the sides and bed. For example, for bed, the parameter is equal to bed width. At this side, if it's trapezoidal, we should find by p is equal to b plus 2y root 2 1 plus m square. Okay. This p for both sides, this and this. It means if we removed for total length of the channel. Okay, this is p for this side and bed. If we want only just two sides, remove b from the equation. This is for both sides, n1 n1. If I want just one side, remove 2. This is for one side. Okay, over summation p to the power 2 by 3. Summation p means the total equation. This is p. This is summation p, all equation. B plus 2y root 2 1 plus m square. Or when you find it individually and then sum it. This table shows the Manning roughness coefficient for different type of material, for concrete, for tile, brick, concrete sewer, compacted earth, and natural river. We have a range. Okay, why we have a range? For example, in concrete we have 0.012 to 0.018, because concrete surface differ from one channel to another. Sometimes the concrete is very smooth, sometimes rough. Okay, this depends on the roughness of the surface. Example 1, find for a rectangular channel 2 meter wide, carries a water at a depth of 0.5 meter. The channel laid on the slope 0.004. Find the discharge using Manning and Chezy equation. F is given. We said that if F is given, we can find N and C. S naught longitudinal slope is given. Depth of flow is given. B is given. So in Chezy equation, V equal to C root to RS. We have S. Just we should find C and R. R equal to A over P. Because it's rectangular, 2 times 0.5 is A. P is equal to B plus 2y. This is R 0.33. C equal to root to AG over F. We have F. We can find C and then apply the equation, find the velocity. Okay, Q is equal to AV. We have A, and velocity A is equal to 2 times 0.5 times velocity, which is equal to discharge. Using Manning equation, find the N first of all. We have C, or from the equation of F we can find N. The same. After finding N, we have R and A. This is N, 1 over N. We have A1, we have R 1 by 6 times S naught. Okay, this is discharge using Manning equation. We have a trapezoidal earthen channel. It is N is equal to 0.25, B is equal to 5, Y equal to 1.1, and side slope 1.5. It had a study to remedy excessive seepage from the channel. 2 proposals: A, line the sides. B, lined bed. Which one is better than? Right. First, because sides material are different from the bed, so we should first find the N equivalent for each case. First, lining on the side. Lining side, it means sides are concrete, so it's N is equal to 0.0112, and it is bed, N is equal to 0.25, so P1, which is bed, equal to 5, equal to B, in 1.025. P2 we can find by the equation 2y root to 1 plus m square. We have m and y. P is equal to 3.966. This is for 2 sides because we have a 2 here. It's n equal to 0.012. So P1 plus P2. We said that P summation P times n to the power 3 by 2. P1 n1 P2 n2, this is power 3 by 2, and all power 2 by 3 over P to the summation P to the power 2 by 3, and equivalent in this case 0.02. In the second, find the same thing, same formula, using the same formula to find the n equivalent. Just replace for P1 n is equal to 0.112, for P2 n equal to 0.025, and n equivalent 0.18, because in the second case n is lesser, so it is discharge capacity is higher, so B is better than first. Uniform flow computation. As we previously said, we have Chezy and Manning equation. In this case, in the computation, we concentration on Manning equation to analysis flow parameter. We have A and R and P. We discussed previously for trapezoidal. This is its formula. We have some variable which is discharge, velocity, depth, roughness, channel slope, geometric. Maybe some of them given and some of them required according to the table. Some cases direct solution is required, and another one trial and error, especially if y and b is unknown. You should do the trial and error. First equation, compute the mean velocity and discharge for a channel of 3 meter. A channel is trapezoidal, it's B 10 meter and side slope 1.5 and longitudinal slope 0.0003 and is equal to 0.012. First, because trapezoidal, A is equal to by plus my square, y times the bracket should be like this, okay. A is equal to 43.5, P equal to B plus 2y root 2 m square plus 1. Also this is P. R equal to A over P, which is equal to 2.09. Apply the equation, find V, and then times A to find discharge, okay. In the channel of previous, find the bottom slope necessary to carry only discharge. In this case, discharge is given, required, find slope. The same idea, just square the equation to remove the root of this slope and make some arrangement to find S, okay, which is S equal to 0.00007112, which is less than the previous S since the discharge is lesser. A triangular channel with an apex angle of 75. Which is apex? What's apex angle? If we have a triangle channel like V, the distance between the angle between these two sides, this is apex angle 75. Okay. Carries a flow 1.2 at the depth 0.8. Find roughness coefficient of the channel. Find N. We can find area A by 1 over 2 times 0.8 times 2 times 0.8 times 75, or find X, which is X, this is X, divide the angle 75 by 2 equal to 37.5, so X equal to 37 times 0.8, because this is Y, which is 0.8. If we have X, we have a bottom of the triangle, and we have this side 0.8 times X times 1 over 2. This is area of this. Similarly, area of the another triangle, the same, so times 2 for both sides. This is 2. Cancel it with 1 over 2 of the equation and solve the calculate the area, okay. P equal to this side plus this side. How we can find this side? If we have this angle, which is 37.5, by cosine we can find this. Cosine equal to this side 0.8 divided by P1. P1 is this side times 2 for both sides, just 2, or instead we can use second because 1 over cosine is second. And R equal to A over P, so Manning roughness is obtained by arranging the equation. A concrete line trapezoidal channel with n is equal to 0.15 is to have a side slope The bottom slope is 0.0004. Find the bottom width. In this case, it's required is B of the trapezoidal channel. To carry, Q is given, normal depth is given. So A is equal to by plus my square. We don't have B, just putting m and y in there. M is 1. In the P the same, we don't have P, just put m and y. Make this arrangement, moving known value to the left side and unknown value to the right side. Known value Qn is not, we have, and unknown it's IR 2 by 3. If I find this parameter by trial and error, we put value of B, find IR. If this side is equal to, it means your choosing value is correct. If it's lesser or greater, try with another value. Okay, the finally B is equal to 16.33 meter. Hydraulically efficient channel section. This is the new subject. What does that mean, hydraulically? This channel hydraulically efficient. If the channel permits maximum discharge, so hydraulically this channel is said to be efficient channel or best channel. Okay, how we obtain this? A minimum parameter, minimum P section, will represent the hydraulically efficient. Why? In minimum P we have a maximum discharge by constant in what? Roughness, slope, and other parameter. So when we say minimum, it means its derivative is equal to 0. So dP by dy is equal to 0. We have a P for rectangular section first of all. B plus 2y. Instead of B, put I over y. So its derivative become minus I over y 2 plus 2, which is equal to 0. Find I. I is equal to 2y e2. E suffix E denoted the geometric element of hydraulically efficient. It means efficient y. We have A, so putting A here, we can find B, which is equal to 2y. So rectangular channel, when B is equal to 2y, 2 times y, this is hydraulically efficient. For trapezoidal, R is also, we can find R is equal to y over 2. For trapezoidal, the same. We have a BP, dP by dy is equal to 0. Okay, then find A. This is A. Putting value A here to find B. We have AB and P. This equation, putting B here to find P. Also, R is equal to A over P, which is finally the same as in rectangular section, is equal to YE over 2. After efficient channel, we have another one which is most efficient. Most efficient in trapezoidal. What does that mean? When in the previous analysis we take the side slope of the trapezoidal is constant, like a value, but if we let the side slope vary, at which side slope M we can construct a semicircle in the trapezoidal channel. This said to be hydraulically most efficient channel. How we do that? If dPe by dm instead of dy is equal to 0, because m is variable, an equation is obtained. Finally, m is equal to 1 over root 2 3 or 16. At this angle we can draw or construct a semicircle in the trapezoidal channel. Also, for another parameter which is AP, E, and BM are shown in the table. For rectangular, the same as efficient, trapezoidal, circle, and triangle, this relation are given. okay, for most efficient channel. We have a example, a slightly rough brick line channel n is equal to 0.1017 trapezoidal channel carrying a discharge of 25 meter cubic per second is to have a longitudinal slope of 0.0004. Analyze the proportion of an efficient channel with side slope 1.5. Second, for most efficient. For efficient, we have a relation of a 1 plus m root 2m plus minus 1 minus m times y is squared. We don't have y, just putting m, we derive a relation between a and y. R is equal to y over 2. You have a q, find y in this equation. When we find y, we can find b. Okay, this is the proportion. Y b is required in this case. In the second one, most efficient. In most efficient, we said that we have a relation for a, p, and r. Using this relation, okay, and putting the equation, find also y and then b. Okay, compound section. What does that mean by compound section? If the section consists of both banks, this called is compound. Mainly this is occur in natural channel like a river, not in artificial. We see the river like this. We have a main stream here and banks are at both sides. During high flood flow, we have a flow in also banks, and during low flow season, we have flow just in mainstream. How we can find the discharge in the channel? By two ways: by the total section or by dividing into some parts. We have a compound channel. Determine the discharge for a depth of flow if y is equal to 1.2, if y is equal to 1.6. We have n 0.02 and s 0.0002 divided. We have mainstream on both sides, so a1 here, a1 equal to a3, a1 equal to 7, this is 7, this side also 7, so both of them are equal. 7 times 1.2 minus 0.9. I want just this. This is y. Totally 1.2. Y is 1.2 minus 0.9, 0.3. This is for a. P is equal to 7 plus 0.3. This side 0.3. Okay, how we obtain 0.3? 1.2 minus 0.9. And R, we find that Q is equal to 1 over n AR 2 by 3 root 2s equal to 0.647, which is equal to Q3 because both geometric shape are equal. This is Q1 and Q3. For Q2, A equal to Y, which is 1.2 times 3. P is equal to, instead of 1.2, because at this here and here we don't have boundary, it's water, so P is equal to 0.9 plus 0.3, 2.9 plus 0.3. Find R and the discharge equal to 2.07. 2 times previous discharge plus this is equal to total discharge. We have an alternative way to find the discharge for entire channel by the total value of A and P. A total is equal to 2.1 plus 2.1 plus 3.6 total area, area 1, area 2, area 3. P total P. R total 8 over total P. Just apply the equation and find Q total, which is equal to 3 meter cubic per second. We have some difference. Okay. For the B, you can solve it by the same way. Just Y is changed. Okay. Thanks for your attention.